Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about complex numbers. Now the question I've chosen to go through here is 2016 Paper 1 Question 1 Part B. In this question we're asked to use the Moivre's theorem to find 1 plus I to the power of 8 in its simplest form. Okay, so now I just want you to be aware that technically there's two different ways of doing this. Technically, there's two different ways of simplifying 1 plus I to the power of 8. The first way is the one that we're going to use is Demoys Theorem. But in theory, what we could also do is, if it hadn't said to use Moivre's theorem, we could just multiply 1 plus I by itself 8 times. But obviously that's completely impractical. And Moivre's theorem allows us, simplifies that process for us. So if it says to use Moivre's theorem, you should realize that that means you need to get your complex number in polar form. At the moment, my complex number is in rectangular form. Rectangular form is when a complex number is in the form of a plus bi. Whereas polar form is when it's in the form of or times cos theta plus I times the sine of theta. So or is, another word for or is the modulus. So often or is referred to as the modulus, and theta is referred to as the argument. So the first step in this question is I need to rewrite my complex number in rectangular form, and I need to get it in polar form. So I need to find my modulus and I need to find my argument. Now there's a formula that we can use to find our modulus. The modulus of a complex number can be found by getting the square root of a squared plus b squared. In other words, the square root of the number and the square root of the coefficient of I. In this case, my a is 1 and my b is 1, which means the modulus is the square root of 1 squared plus 1 squared, which is the square root of 2. So the modulus is the square root of 2. Now I want to draw your attention to the diagram. You'll notice that I've drawn an Anion diagram where the horizontal line is my real axis and the vertical line is my imaginary axis. I've labelled in the point 1 and 1, so that means this coordinate here is the coordinate 1 plus I. Now at this point we should join up my coordinate to the origin. Now I want you to be aware that when you work out the modulus, you're working out the distance from the complex number to the origin. So in other words, I know the distance from 1 plus I to 0, 0 is the square root of 2. So that's what we're actually doing when we work out our modulus. But we need the diagram in order to find our argument. The argument is the angle that the complex number makes with the positive sense of the x-axis. Sorry, the positive sense of the real axis. So my horizontal line is my real axis and the positive sense of it is to the right. So the angle that the complex number makes with the positive sense of the real axis is my argument, or my theta. So it's the angle that I've filled in there. Now in order to do this, we want to form a right angle triangle. So basically all I'm going to do is draw a line straight down from 1 plus I down to the real axis. I know that the distance from the real axis to the coordinate is 1. I know the distance from here to here is 1, which means the distance from here to here is 1. And I know the distance from this point here on my real axis to the origin is also 1. So I know that this distance is 1. So if you think back to your junior cert trigonometry, I now know the opposite and I know the adjacent. If I know the opposite and the adjacent, I can use the tan of the angle. I can use my tan to find the angle. So in other words, I can say that the tan of theta is equal to the opposite over the adjacent, which in this case is 1 over 1. So I want you to just notice one thing there, that actually we know all three sides of the right angle triangle. So we could have used sine, cos, or tan. But you should always use your tan just in case. Because remember, you want to avoid using the square root of 2 just in case you've made a mistake previously working out your modulus. So I'd always recommend using the tan of the angle, which is the opposite and the adjacent. So if I know that tan theta is equal to 1, there's a number of different ways of getting my theta. You can just read it straight off your log tables on page 13, or I can get theta is equal to tan inverse of 1. So if I say, right, theta is tan inverse of 1, now it depends here whether you want to use degrees or radians. Often in the question it specifies, in this question it hasn't specified, so let's just work with degrees. Tan inverse of 1, that means that theta is equal to 45 degrees. In other words, the angle that the complex number makes with the positive sense of the x-axis is 45 degrees. So now I have enough information to write my complex number in polar form. So I know another way of writing 1 plus I is actually or cos theta plus I sine theta. In other words, the square root of 2 times the cos of 45 plus I times the sine of 45. So I know that 1 plus I, that's in rectangular form, can also be written like this. And now let's draw our attention to the power. So on the next line now, we're going to apply our Demoivre's theorem. So I want to get 1 plus I to the power of 8, which means that I want to get all of this to the power of 8. Now be aware that your Demoivre's theorem is in your log tables. So based on my Demoivre's theorem, all I have to say is write the square root of 2 to the power of 8. So I get my modulus to the power. So it's the square root of 2 to the power of 8. So there's nothing particularly special about that. But when I'm dealing with the angles, there is. If I need to multiply cos 45 plus I sine 45 by itself 8 times, actually all I need to do is multiply the power by the angle. So in fact, to apply Demoivre's theorem, all I'm going to do is multiply 45 multiplied by 8. 45 multiplied by 8 is 360. And I do the exact same thing with my next sign. I got sine 45, so that becomes the sine of 360. So that line there, that line alone is my Demoivre's theorem. So I want you to realize that Demoivre's theorem itself is actually quite straightforward. I think students have this illusion, they have Demoivre's theorem up on a pedestal, that it's really complicated. The actual Demoivre's theorem is quite straightforward. And what you should really be focused on is getting your complex number in polar form. So this one simplifies nice enough. The square root of 2 to the power of 8 is 16. The cos of 360 is 1, and the sine of 360 is 0. So if I want to write this in its simplest form, I can just multiply this out. 16 multiplied by 1 is 16. 16 multiplied by 0i is just 0. So my final answer in this case is that 1 plus I to the power of 8 is equal to 16. And that's my final answer for this bit. So I hope this video made sense. Again, if there's anything you're unsure of there, then just let me know in class and I'll try and explain it differently for you.